Hello viewers, welcome to the video lecture series on machine learning. Today's topic of discussion is on a clustering algorithm, and this algorithm is called as hierarchical clustering. Previous session I have explained you about the k-means clustering algorithm. Now let us see the steps in the hierarchical clustering algorithm, and also I will solve one numerical on this hierarchical clustering. Hierarchical clustering is a type of unsupervised machine learning algorithm. Here the data set is not having any label. When we say unsupervised, it means what? There is no supervisor. Unlabeled data sets are grouped into clusters called hierarchical clusters. This grouping is called hierarchical cluster analysis, or in short HCA. In this algorithm, a hierarchy of clusters is developed in the form of a tree, and this tree shaped structure is known as dendrogram. So let me give the explanation for all these statements one by one with illustration and example. Now you just see hierarchical clustering types. One is agglomerative and another is divisive. The difference is what? Agglomerative is a bottom-up approach in which the algorithm starts by keeping only one data point in a cluster and then merging until it reaches one cluster. Divisive is a top-down approach. It starts from single cluster having all data points and split the data points into different clusters below in the hierarchy. So here you can check the difference. In this diagram I am just showing here, you can see on the top in the hierarchy you have the points A, B, C, D. Okay, and suppose if you want to see the functioning of agglomerative and divisive, I'll explain the same with this diagram. Now these data points, if I am trying to split it, then what? It is a top-down approach, and top-down approach is called as the divisive approach. So from the top, that means you have the data points here, you are going to what? Split. You can check in the next level, you have out of the 4 data points that were there on the top in the hierarchy, now you are having next level 2 data points in each of the cluster. Finally, once again this cluster is splitted, and you can check each cluster is having only one data point in the third level. So here we say it is a top-down approach. From the top it is moving to the bottom, and you are able to see that finally it will have only one data point in the bottom level cluster. The middle level clusters can have 2 data points or more than 2 data points in the hierarchy. The top-down approach, it starts from single cluster. You can check here, this was a single cluster having all the data points and split the data points into different clusters below in the hierarchy. Whereas the same diagram, suppose if I have to explain with agglomerative is what? It is a bottom-up approach. Now you can check here, this is the arrow direction. So this bottom-up approach means in which the algorithm starts by keeping only one data point in a cluster. So there in this cluster there is only one data point. Then merge, and you can check here, once you merge you will have 2 data points. This will continue until it reaches only one single cluster on the top. So this is what is your bottom-up approach. When we compare this with k-means algorithm, we have observed that the number of clusters are predetermined, like k equal to 2, and also clusters created are of the same size. Hierarchical clustering has actually the contradicting characteristics. It works on unlabeled data set. It does not decide the number of clusters in the beginning only. Clusters created are also not of the same size. In hierarchical clustering, whatever I gave you the introduction, we'll see the different methods. So these methods are called as the linkage methods. What are these called? These are the linkage methods in hierarchical clustering. So there are 4 types. The first one is the complete linkage. The second one is the single linkage. Third one is the average linkage, and fourth one is the centroid linkage. In complete linkage, the distance between 2 clusters is defined as the maximum distance between 2 data points from each cluster. Once I solve the numerical, this particular definition will become more clearer to you. I'll try to solve in detail one example on the single linkage. Then it is easy for you to carry out for complete linkage and average linkage numericals also. The procedure will be same. I'll tell you what exactly will be the main difference while you are computing the values. So now for complete linkage, it is the maximum distance between 2 data points, whereas in single linkage, the distance between 2 clusters is defined as the minimum distance between 2 data points, average linkage. In this method, the distance between two clusters is defined as the average distance between each data point in one cluster to every data point in the other cluster. We have the fourth type called as the centroid linkage. In this method, we find the centroid of the cluster 1 and the centroid of the cluster 2 and then calculate the distance between the two before merging. So these are the four types of the linkage methods in hierarchical clustering. Dendrogram is a type of a tree diagram showing the hierarchical relationships between the different sets of data. Let me explain one numerical on hierarchical clustering using the single linkage method. What will be the type of the problem statement and how you are going to proceed in order to solve it. So let me explain step by step. So also I'll tell you the different steps in the single linkage algorithm. Whatever are the different types in hierarchical clustering that I have mentioned just now, single linkage, complete linkage, average linkage and centroid linkage, all that comes under the agglomerative clustering. Agglomerative clustering is what? It is a bottom up approach. Just read out the steps here, then I'll explain with an example. Place n sample or the data instances in separate clusters. So initially n clusters are available. Repeat the following steps until a single cluster is formed. Since it is an agglomerative clustering and it is a bottom-up approach, initially in the beginning you will be having some n clusters. Let us take 8 clusters. Now you need to repeat the steps until a single cluster is formed. So your main aim is what? To merge the bottom clusters and then merge the data points that are there in the bottommost level, and you will be forming more than one data point in a cluster which is just one above the bottom level. Then similarly you will repeat until you reach a cluster which has got all the data points and there is one single cluster formed here. Now repeat the following steps until a single cluster is formed. Determine two most similar clusters. Merge the two clusters into a single cluster, reducing the number of clusters as n minus 1. Choose the resultant clusters of the step 2 as the result. So these things will become more clearer when I show you with an example. Let us see one type of agglomerative clustering here, which is the single linkage or MIN algorithm. Single linkage clustering, also known as the nearest neighbor clustering, is a method of hierarchical clustering that defines the distance between two clusters as the smallest distance between any 2 points within those clusters. It works by iteratively merging the two closest clusters until only a single cluster remains, visualizing the process through a dendrogram. So what is the logic you are applying here in order to merge and bring these two data points into one cluster? So those things you will be seeing here in this example. Now this will be the problem statement. Consider the array of points shown in the below table. Apply the single linkage algorithm. So in the problem statement, this table will be given. That means the objects S0 to S4 are given and also the x and y coordinate values are given. And your job is to apply the single linkage algorithm. So this much will be in the problem statement. Now whatever I have written here, okay, this part, you just time being ignore. It is a part of the solution. I will be explaining in later stages. Now at present, you should be knowing that in the problem statement, you will have this table. Now how to proceed? First step is you construct a table like this, wherein you are having rows and columns. But how many rows and how many columns? See in the problem statement, you are having how many objects? Here you have S0, S1, S2, S3, S4. So there are totally 5 objects starting from S0 and ending to S4. So I am placing here S0, S1, S2, S3, S4. Here also S0, S1, S2, S3, S4. Once you place this, then you are going to find the distance between S0 and S0. First you will find distance between S0 and S0. Distance between S0 and S0 is not applicable, so we'll put a dash. Next you will find the distance between S0 and S1. So for S0 and S1, how you are going to find the distance? You should make use of the Euclidean distance. So in order to use the Euclidean distance, you should be having what? The coordinates of S0 and S1. So here I have written S0 and S1 coordinates are 1, 4. You can see here S0 is 1 and 4. S1 is 2 and 8 in the problem statement. So these two, 1, 4 and 2, 8. These two only I am using first in the Euclidean distance. So Euclidean distance formula already you know, you have been doing previously in so many numericals. Under root of x2 minus x1 whole square plus y2 minus y1 whole square. Let us first do between s0 and s1. s0 is 1 comma 4, s1 is 2 comma 8. So I will substitute the values in the formula. Here I am substituting under root of x2 minus x1 whole square plus y2 minus y1 whole square. So my x1 y1 is 1 4. So here is 1 and here is 4, x1 y1, x2 2, y2 8. So after substituting you are getting 4.123. So here I am writing it here 4.123. Next you need to find the distance between s0 and s2. So s0 and s2, how will you find? You are having the s0 values. Now see, first I am writing here one Roman number 1. In this first stage means this Roman number 1 corresponds to your calculations pertaining to the first row. First row is between s0 and s1, s0 and s0, s0 and s1, s0 and s2, s0 and s3 and s0 and s4. So you can take those coordinates from the table. S0 is 1 comma 4 and s2 is 5 comma 8. This is what I have written here. S0 is 1 comma 4 and s2 is 5 comma 8. Use the Euclidean distance and get the result. It is 7.211. Next you need to compute the distance between s0 and s3. So s0 points from the table is 1 comma 4 and s3 points are how much? 12 comma 18. Here 12 comma 18. So use the Euclidean distance, you will get 17.804. Similarly, extract s4 values here, 14 comma 28. s0 you know already, 1 comma 4. s0 is 1 comma 4 and s4 is 14 comma 28 and you will be getting 27.295. So this completes all the calculations pertaining to the first row. Next row you have to compute the distance between s1. See, s1 and s0, though it is there, but s1 and s0 already we have computed here only in the first row, so we will not do anything. Next is between s1 and s1, it is not applicable. Next s1 and s2. So s1 and s2 if we have to take, then extract from the table s1 and s2, this one. In the second row, here I am writing one Roman number 2, this is pertaining to the second row. In the second row you will compute the distance between s1 and s2 using the Euclidean distance. You will get 3.606. Then next s1 and s3 you will be getting 14.142. Then s1 comma s4 you will be getting 23.3294. This completes the second row. Then in the third row you are having s2 and s0. s2 and s0 already computed in the first row only, so we will not do anything. So s2 and s1 we have done in the second row, not required. Next s2 and s2 not applicable, we'll put a dash. Next is what? In the third row only these two. Third row you have to calculate distance between s2 and s3, s2 and s4. So s2 and s3 is 10.630, s2 and s4 is 20.124. Then next you have s3 and s0, which is done in the first row. Okay, s3 and s1 which is done in the second row, s3 and s2 which is done in the third row, and s3 and s3 not applicable, and s3 and s4. So in the fourth row only this one is applicable, s3 and s4, and you are getting 10.198. And in the fifth row, all these are already done. s4 and s0 done, s4 and s1, s4 and s2, s3 and s4 is also done, and s4 to s4 it is not applicable. So this is how you have to carry out. This is your table 1, okay, initial table. Now from this initial table you just find out which is the minimum value. In this entire table you can observe that 3.606 is the minimum value. So in this entire table you can check that out of all the values 4.123, 7.211, 17.3.666, which is the minimum value? This is the minimum value, 3.606, and this is corresponding to which entries? S1 and S2. So now what you are going to do is these two data points S1 and S2 you will put it in one cluster now. So earlier they were in separate clusters, now S1 and S2 has come together. So when you write S1 and S2, similarly in the columns also you should put S1 and S2. The remaining S0, S3, S4 will remain same. Now compute. So this distance between this is not applicable. Now you have to compute the distance between S0 and S1 comma S2. Now how will you do? Because there are 3 points now. So for that we have one formula. We call that as the single linkage formula. So distance between two clusters Ci comma Cj equal to minimum of D of A comma B, where A belongs to Ci and B belongs to Cj. Ci and Cj are the two different clusters. In this formula you have to remember, okay, this is the formula which is used to calculate the distance between the two clusters Ci comma Cj using the single linkage. So DSL is the single linkage distance, Ci and Cj are the clusters, D A comma B is the distance between the elements A and B. Or one cluster is having two data points S1 comma S2 and the other one is S0. So you have to take the minimum. For that what you have to do is, first time you will do like this, S1 and S0. You will compute the distance between S1 and S0. Second time S2 and S0. Okay, this way. When you have in one cluster two data points and in another cluster only one data point, but still if you want to find the distance between these two, you can use like this. First time write S1 comma S0 in one and S2 and S0 here in another. Now you take the minimum. First compute the distance. So you just check from the table only, you will get to know what are the values, what is the distance between S1 and S0 and what is the distance between S2 and S0. S1 and S0 is here, first table. S1 and S0 is 4.123. Here I am writing 4.123 and distance between S2 and S0 from the table is 7.211. So here I am writing. Now from here onwards you don't have to use the Euclidean distance to come to get the value. You have already done and you have placed it in the table. You can extract from there. So between S2 and S0 it is 7.211. Now take the minimum of this, it is 4.123. So now you have to write this value in the table. Now this will be your new table and you can call it as the table after iteration 1. So now you have computed the distance between these two. And the minimum you got it is as 4.123. So you are writing here 4.123. Similarly, you will be finding the distance between S1, S2 and S3. S1, S2 and S3. And how will you do? Just now I showed you S1 comma S3, S2 comma S3. Take the minimum of these. So I am doing it here, those calculation. The distance between S1, S2 and S3 will be S1, S3 first you will write, then S2, S3 you will write, and from the first table S1, S3, the distance between S1 and S3 is 14.412 and here S2 and S3 it is 10.630. The minimum is which one? This one, 10.630. So now that value you can fill it in this table, 10.630. So two values you have done. Next here similarly S1, S2 and S4. S1, S2 and S4. So S1 and S4, S2 and S4. Extract the values from the table 1. So you will get for this 23.324 from the table and for this you will get 20.124. The minimum is 20.124. So you will write it in the table 20.124. So first row you have computed. Now second row and third row and fourth row is very simple because here you have only single data point only. S0 is here and S3 is here. So distance between S0 and S3. Okay. So that I have written 17.804. You don't have to calculate again. You have already done. S0 and S3. Let me check here. S0 is here. S3 is here. And the value is which one? 17.804. So this one I have written 7. S0 and S4 now. S0 and S4. From the table 1, S0 is here, S4 is here and the corresponding value is 27.29 here. So this becomes easy. And the third row is distance between S3 and S1 comma S2 already you have computed in the first row. Distance between S3 and S0 already present in the second row. S3 and S3 not applicable. S3 and S4 you can extract from the table, S3 and S4. Let us see what is the value. S3 is here, S4 is here, and the corresponding value is 10.198. Values in the fourth row are already covered in the previous 3 rows, hence not required. And in the second table, now you just check what is the minimum value. Minimum value is 4.123, this one. Okay. So that value if you take, it is corresponding to S0. And here S1 comma S2. So your data points will be S0 comma S1 comma S2. These 3 will come in one cluster, right? And when you try to put all these 3 data points into one cluster, your table will appear like this. So this table is after iteration 3, S0, S1, S2, S0, S1, S2. The remaining is only S3, S4, S3, S4. So from the distance between these two, it's not applicable. What about the distance between S0, S1, S2 and S3? So same way you have to do. What is that? In one cluster you have S0, S1 and S2. And the other S3. So how will you do? First take S0 and S3, this, okay. Second time S1 and S3. Third time S2 and S3. 3 pairs are there. So the same thing I have written here. Now these values you can easily get from your previous table, that is the table 1. You can extract S0 and S3 is 17.804. I'll show you one entry. S0 is here, S3 is here, 17.804. 17.804. Like that, between S1 and S3 it is 14.142 from table 1. Between S2 and S3 it is 10.630 from table 1. The minimum is 10.630. So you will write the value here. One more calculation in the first row. S0, S1, S2 is in one cluster and S4 is in another. So you will be doing S0 and S4, S1 and S4, S2 and S4. So those 3 I have written here, S0, S4, S1, S4, S2, S4. Extract the values from the table 1, you will get this. Minimum is 20.124. Here you are writing. That completes the first row. Now come to the second row. This S3, distance between S3, S0, S1 and S2 we have already computed in the first row. So done. S3 and S3 not applicable, and S3 and S4. S3 and S4 easily you can take it from the table 1. Between S3 and S4, what is the value? S3 is here and S4 is here. Value is how much? 10.198. Third row calculations are already completed in the first and the second row, hence not required. In this you select which is the minimum. 10.198 is the minimum value. So minimum from the table 3 is 10.198, which is present in the cells S3, S4. Now if this is minimum, then you have to merge S3 and S4. When you merge S3 and S4, your table will appear in this manner. When you merge S3 and S4, you will have only this much in the table. Now there is no cluster with single data point, hence you cannot carry out further computations. Your algorithm stops here. When it sees, actually you were looking for this, so the computation of question mark in the above table is not needed, as no other items are left. No other items are left means there is no cluster remaining with single data point. Therefore the clusters S0, S1, S2 and S3, S4 are merged. Now you can completely merge this S0, S1, S2, S3, S4. So this is how you have carried out this algorithm, and finally you have merged all the data points into one cluster. And if you want to sketch the dendrogram for this, you can see here the distance. Okay, this is S1 and S0. Okay, this height what you are getting is 3.606. Whatever distance you computed between S1 and S0, we have to start sketching the dendrogram with minimum value. The minimum value is 3.606, which is the distance between S1 and S0. So you are writing S1 and S0, and this height, how do you decide? This is your value here, the distance value on the y-axis 3.606. Next, S1 and S0 became one cluster and S0 is in another. So to compute the distance between S0 and S1, S2, you got the value as 4.123. So now your S0 is also getting merged with the previous cluster. Previous cluster is having 2 data points. So this height is how much? 4.123. Initially it was only S1, S2. Now S0 joined, so it became S0, S1 and S2. After that, and the distance between S3 and S4, and these 2 points, if you take the distance between S3 and S4, it is 10.198. so this whatever height I have sketched here is your 10.198. okay, so you are having one cluster here with S3 and S4 and another cluster with S0, S1 and S2. Hope these were the two clusters. You can check, cross verify here with the diagram. S0, S1, S2 and S3, S4. S0, S1, S2 and S3, S4. So S3, S4 is here, S0. Now finally what happened is this S0, S1, S2 got merged with S3 and S4. So that particular indication you have to show it. These are the heights. I just wanted to show you this yellow color. S0, S1, S2 is now merged with S3 and S4. So this is how you need to sketch the dendrogram for the given numerical. For any numerical, if it is asked in the question sketch dendrogram, then you are going to carry out in this manner. So that was about the single linkage algorithm. The other algorithm which I said, complete linkage, suppose if there is a numerical, the same data set is given, but it is asked apply the complete linkage or the max or the click. These three names are there for this algorithm. That time you need to use the same procedure. Only difference is there you were taking the minimum of the values whatever you have computed earlier, the distance values between the data points. Here you should take the maximum. So this is the only difference between this single linkage and complete linkage algorithm. Hope you find this session helpful. Please like, share and subscribe to my channel. Thank you. Bye bye and take care.